Good morning all. This is my favourite type of electronic gadget. It's a DC to DC converter. And it's nicely presented in this package. You can see exactly what you're getting, which is the control panel unit. If I can get that out. Which is one of these colour LCDs, I think it is. And some buttons there, and then a rotary encoder, on-off switch. And the module, because this is a more powerful one, some of them are available just as this box. And there are some connections on here, everything's contained in this box. But on this one, because I think it's 12 amps, you've got this external unit which does all the high power stuff. So this is the DPS 3012, 30 volts, on the output, 12 amps, it's quite high power. Input voltage range is 6 to 40. Output voltage range is 0 to 32 actually, up to 12 amps. So wiring this up looks pretty straightforward. We've got two ribbon cables here, they appear to be the same. One's for LCD and one's for the keyboard. And correspondingly on the power board, we've got an LCD connector and a key connector. So let's get those connected up. So that's the keyboard and display module wired to the power module. Now I just need an input for my 2.1mm jack, so I'll just stick that in the input connector there. So those connectors mate up pretty reasonably with a couple of bits of thick wire. So let's plug that into there. And then I'm ready to apply my input power. So a quick double check, input voltage range is 6 to 40. And I'm at 12.8, so we should be fine. Okay, wait for the bang. Oh, no bang. Boot up screen, and we have volts, amps, and watts in the rather dark purple. Let's zoom in a little bit. So what can we see here on the display? Well, we've got the set output voltage is 5 volts. The preset current limit for the output is 12.1 amps. I might lower that a bit. These are the actual current values, so there's 0 volts on the output. Now that will change if I switch it on. That goes up then to 5 volts. Switch it back off and it tracks down. There's a capacitor on the output, which means that it goes down a bit slowly. Currently no amps are being drawn and there are no watts. You can see the input voltage is 12.79 volts. That's coming in on this connector here from my solar power system. So now I'm going to need some sort of load, so let's use my favourite load, which is a light bulb. I can put that in there. Let's do that. Okay, my load, the light bulb is in place, so let's switch on and put 5 volts into it, and we get a dim glow. And now we can see how many watts are being drawn, 5.85, and how many amps, 1.16. Excellent. Now I need to work out how to adjust the set voltage. And for that, it seems like you have to press set, and then you get all the parameters which you can set. You press the rotary control on the one you want to set, and you have coarse control there, 5 volts, 6 volts, 7 volts. Or press it again, and you have a finer control, so that's tenths of a volt. So let's click that back onto the 5. Let's go up to, I don't know, 10 volts. Enter that. I presume that's entered. Come out of that. Yes, so that's now set for 10 volts. And if I switch that on, the lamp is correspondingly brighter. 9.99 is being measured on the output. 1.64 amps, 16 watts. Super. Now, I've been playing with this for some time now, and I'm starting to like it even more because I was a bit concerned that it didn't seem like you could control the voltage and current limits live on the main monitoring screen. Nothing seemed to do anything, but you actually can. If I press V, I get a little highlighted box there in the voltage field, and I can now adjust the voltage in hundredths of a volt. Now that might seem a bit too, I don't know, granular. So if you take that back to there, if I press it, I can now adjust that in tenths of a volt. And if I press it again, I can even adjust it in whole volts. So this is great. This means that you can actually adjust the voltage, and if you press the A button, the current, either hundredths of an amp, tenths of an amp, or whole amps, that's the current limit set down to 1 amp, you can adjust these fields from the main monitoring display. Now, what else can we see on this main monitoring display? Well, we've got a lock icon here. That's unlocked at the moment. That means I can press keys and make things happen. If I press and hold the rotary encoder, that locks, and now nothing works, none of the buttons work. Press and hold the encoder again, and that unlocks. The icon below, the blue tick, now that will change if there is an overvoltage, overcurrent, or overpower protection event, and I'll come back to that in a moment. CC and CV, so currently that's in constant voltage because I'm limiting at 10 volts. We're drawing a bit less than 2 amps, so if I change the current limit, let's do that by going to the amps, and I'll turn that down to 1 amp. Now you can see that we're limiting on current, not voltage, and that symbol has changed to CC. And then the icon at the bottom is simply a green or red power symbol to indicate whether the output is switched off or on. Now, switching to the other display by pressing set, you can see that we can set a whole load of parameters here. Voltage set, that's the voltage limit. Current set, current limit. The overvoltage protection setting, so that's currently at 18 volts. If the output went over 18 volts, this unit would actually switch off. It would do the equivalent of pressing the on-off switch. So that's what these protection things do. Over current protection and over power protection in watts. The brightness of the LCD screen, it says brightness LED, well maybe the backlighting LEDs. Let's just try coming down to that and adjusting that, and you can see that that goes pretty dim. What else have we got? We've got the memory presets, which are really quite unfathomable to me at the moment. And then the final item is initialization setting, which can either be that the unit is off when you power it up or that the output comes on when you power it up. Now, what about these protection parameters? Well, I've noticed that if I put it just to 1 amp, it takes quite a long time for the bulb power to come up because of thermal effects on the filament, but eventually it comes up to just over 3.5 watts. So let's set the power protection to 3.5 watts. So let's go to single digits, bring that down to 3.5 watts. Okay, that's set. Now when I switch on, notice that it turned itself off because it was already drawing more than that. If I switch it on, it takes quite a long time to get up to 3.5 watts. And when it does, and when it goes over 3.55 watts, and the output is still on. Yeah, I set it to 3.5 watts. That's not triggering. What's going on? Okay, a slight tweak. So I've now got 1.01 amps. Let me switch it on. Now I set the over power protection to 3.5 watts. It doesn't actually trip until it gets to 3.6. But you'll notice when it does eventually climb up to 3.6 watts, then the output is shut off and we get OPP, which means that we had an over power protection event.